Lesson 5, calculating measures of center and variability. And our aim today is going to be the same. Let's calculate measures of center and variability. So, I'm not gonna write that. All right, so 5.1, calculating centers. Decide if each situation is true or false. Explain your reasoning. The mean can be found by adding all the numbers in a data set and dividing by the number of numbers in the data set. Is that true or false? If it's true, you can just say it's true. If it's false, explain why you think it's false. And this would be true. How do I know this? That's just what our formula is. We talk about adding all the numbers in a data set. We talk about that being called a summation. Right? If you think when you add two numbers, you get a sum. When you add a bunch of numbers together, you call it a summation. We sometimes see it expressed as the Greek symbol epsilon. Dividing the number of numbers in the data set, yeah, right? We're trying to find out on average. I know that's not good practice to define a word with a similar word, but we're trying to find the most typical value. So if I take all my numbers and I divide it by the number of numbers, it's like I'm breaking up the total into equal groups. So each of those equal groups would be what a typical value would be for that situation. All right, the mean of this data in the plot is 4. Try and determine that. If it's true, write true. If it's false, say why you think it's false. Okay, so the first thing I notice when I look at this graph is that it's symmetrical. And what's nice about symmetrical graphs, especially ones like this that are perfectly symmetrical, is that the mean is going to be equal to the median. And they're both going to be in the middle. So if I'm looking at this graph, my middle right here is 3.5. And I can actually do the work to write that out to prove that. But you can see pretty clearly that that's where the middle is. So let's just double check that. And so I get 3 and 4 in the middle. So 3 plus 4 over 2 is equal to 7 over 2, or 3.5. So my assumption was correct. So false. So I'm not sure what they did wrong to get 4, but if it's a symmetrical distribution, that mean and the median are going to be right in the middle. All right, 3. The median of the data set is 9 for this data right here, these 5 numbers. So go ahead, is that true or false? So for me, it's kind of difficult to look right away and see if that's true or not. So I'm going to reorder my numbers in chronological order. Chronological is not. Chronological means in order of time, in numeric order, from least to greatest. So I'm just going to use my typical method. So that's false. 5 is need to order numbers. Right here, they just must have gone like that and gotten 9. Well, we got to put them in numeric order first before we do stuff like that. All right, so the median of the data in the dot plot is 3.5. Let's take a look at that. So it looks like the median could be somewhere over here. It's hard to tell just by looking at the dot plot. So I could write out the numbers, but I actually want to put this in my calculator because there's a couple things I want to look at when I look at this graph. So I'm going to go stat. I'm going to fill in list 2 now, because maybe I want to use list 1 for something else. Who knows? Maybe it's important data. 2, 2, 3, 3, 3. I'm pressing enter after every number. All right. So before I do this, take a guess. Do you think that median is going to be 3.5, higher, lower, or exactly that? All right. So there are no wrong answers there, really. Say whatever you want. So don't freak out if it says told you got the wrong answer. I don't care. I don't grade if you got it right or wrong. Just the effort and completion. Okay. So let's do 1 var stat. But since I'm in list 2, I got to press second and then 2 to make sure it does L2, not L1. All right, so I can see, I'm just gonna write down my mean because that's interesting. It's 4. And my median is 3.5. So they did a good job, it's true. The median is 3.5. But one thing I want you to think about, why do I know for a fact, just by looking at this graph, that that mean was always going to be greater than my median? Well, what would we call this graph, right? This is a graph that is skewed right or skewed positive. Right, I've got trailing off to this right side, to the positive side, to the right side. So that means it's pulling the mean away from the middle, and so that mean is going to be a little bit higher than the median. So in a case where you have skew, it's always better to trust the median, not the mean, because the mean can get affected by that skew. Those little, I don't want to say the word outlier because there's a mathematical definition for that we'll get to later. But these values that are on the skew here are pulling that mean away. The median is less affected by that. So I always say the median is a better measure of center when there is a skew. All right, that's all for 5.1.